Aloha and welcome to this screencast in which I'm going to give you a walkthrough of a sample model in Play. This is kind of an elementary model, but it does, I think, illustrate many of the essential features of model development. So what we're going to do is first we're going to talk about what the model is, and I'm going to show you this package that integrates into Google Docs called Lucidchart that makes it very easy to make data model diagrams. That's kind of an essential step in the design process, is just creating a picture of what your entities and relationships are. So there needs to be a good, fast, cheap, simple way to do that. I think Lucidchart is a good way to go. And then I'll walk you through the code that I wrote to create this model, and finally the way that you can test it. I want to give a shout out to the Play for Java book that's currently under development. They use a very similar example data model in the book, and I kind of swiped the data model to do this. The implementation is a bit different than what they do in the book, but if you're interested, you could buy the book and you could see the way that they do it and compare and contrast. So in a nutshell, what our sample application is going to be a kind of warehouse management application in a very simple way. So you have warehouses. Each warehouse has an address, and a warehouse is filled up with stock items. Stock items are actually instances of a product. So your product might be Kleenex, and a stock item is a pallet of Kleenex boxes or whatever. And then you can have associated with each project any number of tags which are descriptors about the product. And so you can ask things like, you know, is a product in stock, and if so, at what warehouse is it available? Given a certain tag, you know, cleaning item or whatever, what are all the products that satisfy it? Okay, super simple. And so what I want to do now is shift over to show you a little bit about Lucidcharts and how we might diagram that. Now you have to go to lucidchart.com and you install it into Google Docs, and when that happens, you'll have this little Lucidchart diagram thingy in Google Docs, so you can create instances of this. And this is the one that I created, and basically when you install Lucidcharts by default, it doesn't have these entity relationship shapes defined. So you have to go to this More Shapes menu and check this box. There are some other ones that are checked by default. I unchecked all the other ones, so I could just have that one. And once you have it, now you have this ability to kind of basically take, you know, these entity boxes and move them into the drawing area and label them and add fields and so forth. And so just to, you know, for fun, let's make a new entity, and I'm just going to keep it with one field called ID. Actually, you know, for this part of the design process, I don't even really care what the fields are. We'll get into that a little bit later. So now I have an entity, and let's say I want to have a one-to-one relationship between warehouses and addresses. What I do is I click over that, you know, one of the little bubbles, and I connect it. Now I've got this arrow, and I basically fix the line shapes by going over to this area, and you can see that I can now say, you know, one and only one on this end, and then I can go to the other end and replace the arrowhead by one and only one, and now I have that. And then I can, if I want to just make the thing look good and consistent, I can draw one of these things over here, and then I can double click inside and say each warehouse. Having problems typing. Each warehouse is associated with an address. Something like that. Okay? And in fact, one of the things that I'm going to ask you to do in the assignment is build one of these diagrams just that looks basically just like this in your own version of Lucidchart, just so you can walk through the part. It doesn't take too long to do it. So anyway, that I think is a nice way to create diagrams. You can do some nice things, like you can say download as PNG, part of current page, print quality, select area, and then you can basically just drag, and what will happen is a PNG file will be downloaded to your desktop that has that particular picture. So I can click on that And well, you can't see it on that screen, but anyway, it'll create a PNG that you know, nicely displays that particular image. So all in all, I think it's a pretty nice way to go when you're trying to show your data model diagrams. Okay, so now what I want to do is switch over to Eclipse and walk through the application that I developed that implements this particular data model. And what you need to know, the important thing to know for this, is that I just said create play new play model example, and am working with essentially the hello world application. So I have not touched the application.java file, and I've not touched any of the views because I'm not using the controller part of the MVC architecture or the view part of the MVC architecture in this example. I'm just working on the model part in isolation, and that's kind of super nice that we can, you know, kind of decouple development of one part of the architecture from the other. In fact, that's, you know, one of its nice advantages. And you can see in the testing package that in fact I've deleted the two test files that comes with the Hello World application that kind of tests the control a little bit and tests the views a little bit, because they had warnings and they're just irrelevant for what we're trying to do now. But I have added a new test class, which we'll see in a minute. Okay, to set things up, so basically, so I created a new Hello World application. I got rid of the test files. The next thing I had to do is configure this application.conf file. And essentially all I had to do is uncomment these lines here, and then I also added in this line apply evolutions.default equals true. That's just to make sure that, or what that means is that the object relational manager eBean will go ahead and update schemas automatically in the background as we do development. That makes things go a lot more smoothly. It's not good for production because you can lose data if you have a schema update that you're not kind of managing correctly. So you really don't want to have that in production, but for development purposes it makes things nice when you're only loading test data and don't really care what happens to old data in the system. Okay, so that's the configuration that we have to do, and once we've done that, just to show you how we test the system or run the system, you know, we go into our directory holding the application, and then we invoke the test play command. We invoke play, and then we just to start from scratch. So I'm in the directory. I invoke play. That brings up the play console, and then I can say test, and then it runs the tests. And we can see we didn't get any errors, and that's essentially the kind of the end of the road for this part of the development process. Is I want to build my model, and I'm going to write some tests that test my model. This shows that my model has been appropriately implemented, and I'm all good to go on to the next part of development. So that's kind of what we're trying to accomplish at the end of the day in this kind of approach. So now let's look at the four entities that I have in the system. There is a product.java, and I'm just going to expand this so you can see all of the different import statements that are involved with this. And you can see that the product class has an @entity annotation that extends the model. It has a public long ID class that's annotated with @ID. Eclipse likes to have serializable classes have a serial version UID, so I added that one in there. And then we've got a couple fields associated with the product to talk about it. And then we've got two relationships. One is a relationship back to the tags, and that's a many-to-many relationship. And one is a relationship with stock items, which is a one-to-many relationship. So one product can be associated with many stock items. Any stock item can be associated with only one product. And many tags, or a product can be associated with many tags, and a single tag can be associated with many products. So that's a many-to-many relationship. You'll notice that for all these annotations, I'm adding the parameter cascade equals cascade type equals all, and that's to ensure that when the system is trying to persist instances of a product, if it comes across a stock item or a a tag that hasn't yet been saved into the database and thus doesn't have its own primary key yet, it'll go ahead and create that object and save it out. And that just, it's very convenient to have that cascading. It makes your code a little nicer. Okay. As I noted in our model design guidelines or hints, for any given bidirectional relationship, and in these data models, every relationship is a bidirectional relationship, you have to specify, which field is essentially going to be the column that holds the foreign key to this particular relationship. And you do that generally on the many side of a relationship. So in this case, when we say at one to any mapped by product, what we have to do is go back to stock item, and we see this field here. And so that's the field that's going to correspond to a column in this particular entity that's going to hold that relationship. Okay? And as you can see, given a product has this at one to many relationship with stock items. Stock items have a many to one relationship with products. Okay? So it's kind of the inverse relationship, and we have a field holding, the backlink in each case. And that's the essential nature of bidirectionality. Okay, going back to our product, what else do we have to know about? I've got a little constructor here that just makes it easier to make them. And then I've got this other static method called find, which is going to appear in all of our entity classes. And essentially what that's going to do, it's going to return a new instance of a finder, okay, which is a ebean library function, which enables you to find instances of a product in a kind of a query. It's your API or your access to a query mechanism built into ebean. Okay, and you'll see how that works in a second. So there's our model of a product. Pretty simple. And now, if you understand that, what you'll be able to see is that all of the rest of these entities basically look just about the same. So here's the stock item. You can see it has a long ID. It has a many to one. Many stock items can be associated with one warehouse. So we have that. We have our cascade type equals all. We have many stock items can be associated with a product. So we have another many to one. We have a quantity. So how many of the products are associated with this particular stock item? We have a constructor that enables us to make these things a little more easily, and we have our finder method. Okay. Going on to tag. Tag is very simple. It just basically holds a name, but we've got this relationship between tags and products, which are many to many. So you can see we've got a list of products here, and we have this at many to many relationship. As well as our long ID and our serial version ID, and we extend the model. And then just so you can see, here are all the import statements. Okay. Finally, we have the warehouse. Here are all the import statements. You'll know when you get to the assignment why I'm being very careful about revealing all of the import statements. I want you to be able to see in this screencast all of the code associated with this program. Okay. So the warehouse has a mapping. One warehouse can be associated with many stock items. So we have this at one to many relationship. We're going to the foreign key for this will be held in the column warehouse on the stock item side. So you can go back here and you can see there's this warehouse. Okay, and what else do we have to know about it? It's got a name, it's got the finder method, and conspicuously absent here is a relationship to an address entity. So you can see in my models I don't have the address entity. That's something I'm going to want to ask you to do for your assignment, is to implement everything you've seen here so far and then add that one remaining relationship to an address, which is a one-to-one relationship. It should take you about 5 minutes, maybe a little more to add it, but not too much more. Should be real simple, and after you get done with that, I think you'll feel a lot more confident about going ahead and doing your own model development. All right, so there we have our model. Okay, product, stock item, tag, and warehouse. We have our data model diagram that we developed in Lucidchart, which we can refer to, and you'll see, if you go back and you look at the little crow's feet notation, you'll see that that matches up with these relationships between the entities. You can see that anytime an entity participates in a relationship, there's always a field that exists to specify that relationship, and that field is going to correspond to a column in a table. Each entity is implicitly specifying one table that's associated with, and when we have bidirectional relationships, we don't need to store that relationship in both tables, both entity tables participating. So we use this map by to say which one of the tables is going to be used to represent that relationship. And I can't think of anything else to say. Obviously, you can get way more complicated with these data models, right? There's all sorts of stuff if you start reading about this. In order to make an efficient, high-performance, database backend, you can do a lot of tricks with this stuff to make things work better. I'm not showing you any of that stuff because my first and most important goal is to enable you to quickly develop code that works. Okay, and so a lot of these things about bidirectionality and so forth are not necessarily the most scalable or efficient in the long run, but in the short run, it gets something working that's easy to understand, easy to debug, and easy to work with. And I think that's more important at the very beginning. Later on, if things don't work good, if you're not getting the performance that you want, what you do then is you profile and you determine, well, where is the problem in my code? It may turn out to not have anything to do with your data model. This is kind of an idea, don't prematurely optimize your code because you might be optimizing the wrong spot. Okay, so we've got our data model developed. Now the question is, how do we know whether or not it works well or not? Let me show you all of the imports associated with this particular class. And then I'm going to scroll down, okay, and show you this model test class. In fact, I don't need this at all. So, and as I talked about in the page on the helpful hints for development of data models, there is this kind of boilerplate code where you create this private fake application and you have a before and after method, which before each instance of a test method, you're going to create a new fake application and start it up. That'll get the object, the ebean ORM going and make all the basic connections on a clean database. And then after you finish the test case, you stop the application. Okay, so I've got copies of that code in the page associated with this assignment. So let's just move right on to the test model method, which is where all the good stuff happens. And basically what we're going to do is we're going to start and we're going to create instances of Java entity classes and express all the relationships between them. And for this simple test, we'll create exactly one tag, one product, one warehouse, and one stock item, and link them all together. Okay? So here's the tag item that we create. Here's the product that we create. And then we're going to add the tag to the product, and add the product to the tag. Okay, so now these two things are linked together. Next, we'll create an instance of a warehouse. We'll create an instance of a stock item, which is associated with that warehouse. Okay, and then we'll add the stock item to the warehouse and the warehouse to the stock item. Okay, so everything's all linked up between those two. Once we've created that fully linked model, we have this, because we've extended the model class, we have this method that we've inherited from the superclass called save, which invokes the ORM to go off and save all our entities and relationships in the database. So we basically have these four instances, we just invoke save on them, and everything is all saved away. Okay? We hope, right? We've invoked the save method, and presumably that's what should happen, but maybe in practice it hasn't worked exactly the way we want. Maybe we've forgotten an annotation, or something else is not set up the way we want it to. So you can't just assume that because this code completes correctly that we've actually got what we want. The way that we figure out whether we've got what we want is by then invoking that find method, okay, that we've associated with each of our entities, with the chain method find list. And what that's going to do is that's going to go off and that's going to find every single instance of a warehouse in our database and produce this list, and we're going to bind that to this new variable called warehouses. Okay, so we do that 4 times, and now what we have is in the warehouses, tags, products, and stock items variable, we now have a new copy of our data model, but this time it's a copy of the data model that's been retrieved from the database. Okay, so it's important to understand that, you know, we have this warehouse stock item, you know, we have these Java classes up here, okay, that we created originally, but once we invoke the find method, now we've got this kind of new entire copy of the data model that's not been constructed by us manually, but actually been constructed through retrieval from the database. And this is the one that we want to check to make sure that it's, you know, got the right stuff, okay, and all the relationships and so forth are appropriate. So the way I'm doing it here is the first thing is just simply to do kind of a sanity check to make sure that these lists that have been returned by the find methods all contain exactly one entity. If they contain more than one entity or they contain no entities, then of course we'd be in immediate trouble. And what we find is, okay, it's all good. They all contain exactly one entity. So far so good. Second thing to do is to check to make sure that all our relationships are appropriate. So we know we have a relationship between a warehouse, our single instance of a warehouse, and our single instance of a stock item. So we check to make sure that when we retrieve the first element, only element, from the warehouses, and then we get that list of stock items that are associated with that warehouse and get the first element and only element of that, that should be equal to the one and only stock items element. Okay, and it turns out, if this passes, which it does because we just saw it, that in fact that's true. And then I go through, so that's the warehouse stock item relationship. I do the inverse link stock item warehouse. This time I get the stock items element, and then I get its warehouse, and I compare that to the one and only element in the warehouses list. Okay, and then so on and so forth for all of these 3 bidirectional relationships. Okay, and at that point, basically, we're you know, we've tested to make sure that our data model is okay. We have all our entities that we saved, and we have all the relationships that we saved. So presumably everything's good. If you have a more complicated data model, you might want to check additional properties of it. But just in terms of, you know, are we persisting the entities that we think we're persisting? Are we, you know, establishing and persisting the relationships that we want to persist? That's good enough. But what I wanted to finish with was this code that I wrote just to make it kind of clear, you know, how it is that you manipulate the existing data model, and to show you, you know, like, you know, how that all works. So let's say, for example, we take our product instance and we delete a tag from it, and we can do it in this way by basically clearing the list associated with the tags, and then we save that. Okay. Now the thing to note is, of course, that, you know, it's not going to change the data that we've retrieved from the database previously up here. Okay, so I have a little assert here that if I look at my products list, which was up here, it's not the case that you know, that has been changed. Okay, so what you have to do is, after you've done this save, of course, you have to do a new find. Okay, to actually create a, you know, retrieve a new instance of the product which has had this particular change made to its state, in order to make sure that everything's okay. All right, and once we've deleted all the, you know, now that there is no tag associated with the product, we can actually go ahead and delete that tag in the database, and then we'll find, if we try to retrieve a list of all the tags, that's empty. Okay, so you can kind of look at this code. You might want to type it in, play around with it, make some changes, just to get really comfortable with the idea that the way you're going to handle HTTP requests in your business logic is you're going to go to the database, make this kind of local copy of a portion of the state of the database. You're going to manipulate that local copy in a certain way, and then you're going to persist out these changes to the database so that the next HTTP request will have access to them. Okay, I think that's, you know, just once again, then we can, you know, after making these changes, we didn't make any changes, but let's say you were doing development, you'd go back, you'd run this test method, and you'd find that everything was good, or you'd find that things weren't good, and you'd make the changes that you need to make. It turns out that running JUnit within Eclipse is not possible kind of out of the box, unfortunately, and yet I have come across a link which provides some example, a way to kind of, there is a plugin for Eclipse for the eBean ORM, and it turns out that one poster has said if you kind of install that plugin, then these unit tests work for him. I haven't had a chance to check that out, so I haven't done it, but I will at some point in the near future, and let you know if it works for us. All right, hopefully now you've got a good sense for data model development, at least at the beginner level, and have fun.